Hello students, welcome to EduCell. In this video, we are going to discuss about max flow problem using Ford-Fulkerson algorithm. It's a part of our network flow. Before going in detail about the algorithm, we should know the prerequisites of network flow. Here in this network flow, we have certain prerequisites, or you can say terms to be known, named as source, sink, bottleneck capacity, residual capacity, augmented path. These are certain terms which we will be using throughout while solving the problem. Before going in detail about the algorithm, one more thing we should know: why network flow is important for this algorithm and what is this basically. So network flow, in general term, I must say, we have used in our traffic solving problems in computer networks, or else you can say a simple example nowadays we are providing is like we are having water taps in our home. Okay, so where we're staying that we are having the taps, and the problem is like it's stored, like the water tank is there on the top of it. There are definitely so many pipes are getting connected, but whenever we need it, the flow should be a proper flow. We should be really interested for, like the proper flow in the sense, like if you're going for a bath, so in that sense what exactly it does, like if the flow of the water, okay, if you're using shower there, suppose if your flow is not that much adequate, or might be that it's not a proper flow which you are expecting, it's not a proper flow there while you're using sink, or might be you can say shower, suppose you are going to take it and it's not a proper flow, that time what happened, like the definitely the tank is on the above of it, above of any roof. So what it does, like there are many connections, okay, from the tank to the tap. Okay, so tank is the source there, and you have the tap with you, which is a sink. Let us take an example of sink. Why I'm using these terms? Because these terms are going to be used in this network flow. So the flow should be proper. That's why we are reading it as maximum flow. Means we may say it's a flow, but maximum means as per our requirement we are getting it. That's why we are saying it's a max flow. Okay, in short we are saying it's max flow, but if I'll say it's a maximal flow also, it's correct. Okay, so source is something where we do not have any inward edges, only outward edges would be there. Like in degree is zero, means not towards anything. Like if I told you, like you just think the example of the water tank, we will store the water there. There is no other path to be connected, only one path. Might be you can consider those a practical problem. Definitely we are storing the water there, that's why we need one pipe or two pipes max to max. But from there, whenever we are expecting the water should be utilized by us, that time we shouldn't take any other path because we are storing the water there. So here also we are thinking the source. Okay, next, sink, or you can say destination also as a part of sink, where out degree is zero, means no such out degree will expect there, only this is the end point. Okay, next, bottleneck capacity and residual capacity, which is much needed to understand it well. Why? Because bottleneck capacity, you just think like we have a water bottle. So water bottle, definitely the mouth of the bottle could be smaller. Why? Because we need a flow. Might be you can think it's a max flow, but whenever we are taking that one, so the bottle, the neck of the bottle should be slow or the narrow as compared to the body of the bottle. Or might be sometimes you have seen like the still for all the cases, like the opening mouth with the body is also same, not an issue. But we are talking about those bottles who are having the neck is small in size. Why? Because it's easy for us to intake it well. Okay, so that is why we are focusing on the capacity, though we are focusing on the pipes. Based on the pipes, like if the capacity is good, so definitely the flow is also we will expect in a good way. Sometimes the pipes are bigger, sometimes the pipes are also smaller. Okay, so that is what exactly the bottleneck capacity is. If any there is a path, like we can have source to, might be there are many distances. If you have sink is represented as T in our book. Okay, source is represented as S, This is not always correct, but ST we are representing as per the book. In future, there are certain contents you can expect like SD code. But there are many concepts out there. That's why I'm representing it from S to T. Okay. Next, residual capacity. Residual capacity is some capacity you can say like we have certain original capacity of the like whenever we'll go in detail that could be very much easy for us to understand. Before that we are just discussing about what are the prerequisites to be known. Okay, like residual capacity, which is like original capacity with the current flow. Whenever we are writing it, so the flow should be written in this order, this way. Flow will be in the left hand side, and the right hand side will be the capacity. Capacity, or you can say it's the original capacity. Original capacity of what? Like the path or the pipe, you can say. Okay. Flow this side, original capacity will be the right hand side. Next, augmenting path or augmented path. Once we have done the proper flow, we can say it's a augmented path as per the English. Okay. Whenever we are not doing it, or might be we are in a processing, we can say it's a augmenting path. There are two types of augmenting path. One is non-full forward edges. You can say there is only forward edges. Okay, from S to T. S to T. Next, non-empty backward edges, like you can expect the backward edges from any point. Suppose this is R, from R you can expect some backward edges. There are also combinations of this also possible, but right now in our example we will be focusing on non-full forward edges. Okay, let us start with the Ford-Fulkerson algorithm. Here the solution steps I have written for you. As for the solution step, first we will understand how it is running. Once it is done, then we will be focusing on our one of the problems. Once it is easy for you to understand, then we can say all over the idea like which we are targeting to read it using the Ford-Fulkerson algorithm, finding the max flow. That could be easy for us once we'll complete this algorithm steps with the implementation of it. Okay, so step one, assign initial flow as 0. Whenever we have like question I'll be having in the next slide, I'll show that one, but still the steps we should know first what it represents, like assign all the initial flow as 0. Next is select any augmented path. You can say it's augmenting. Sometimes also you can see it like augmenting and augmented. The main reason actually why I'm using this as augmented, once the path we have selected, once we have the residual capacity of any, once you are selecting any path like from source to destination, so that path is considered as augmented path. This path should be having the connection from source to destination is called as augmented path. Otherwise we cannot say any path as augmented path if the path is considering source to destination only. So this is what it is representing. Okay, source to sink. Okay, so once the path connected, the connected paths are from source to sink, we have, then we say it's a augmented path. If you're doing work on this, so we can say it's augmenting path. Once it is done, we say it augmented path. Okay, so find the residual capacity and update the final flow as previous flow, whatever the previous flow you have, with the current residual capacity, or you can say I'm just saying it in a residual. Okay, like we should know why it is important, so that's why I kept bold it next of that augmented path. Next, step 3, we will be resetting the path if the residual capacity of the selected path is 0. Means we will be like, you can say, if in a class uh, if a teacher is teaching you, might be he or she knows it well, like how much assignment we can give as a just for a you can say the people will understand. Like suppose let us take your faculty is giving you 2 assignments for 1 week. Okay, so it's good enough to tackle all the problems. If you can think, for each day two different assignments have been given to you, so that could create a pressure. This is what a management of pressure is all about, the network flow. We are reading that one only. Okay, so a residual capacity, like what's your capacity? Suppose you can do you can read up to 4 hours, suppose, for a day. Okay, so the assignments have been given to you. The assignments will take 2 hours. So definitely you have 2 leisure hours for other study. Okay, or other studies like study material you can go for, or might be network through the internet you can surf. Just think about, like, you have 4 hours for the study, you can dedicate max 4 hours, and 4 hours is given for the assignments. So the residual capacity is 0, means you do not have any other hours to recap other subjects too. Okay, this is what the problem is. We are actually trying to release our pressure. This is what exactly we are doing in our network flow. Okay, so step 4, what it has, step 2 and step 3, we will be continuing until the flow from the source to sink is having the residual capacity as 0. Until that we will be running it. Like each path we have to focus, like from source to sink, whatever the path that we are having, if we'll cut all the source as residual capacity as 0, then we say we stopped here, because from source we can expect there is a flow. Okay, if source, the path which are connected, immediate connection to the source, if the paths are having residual capacity as 0, then we cannot flow it. This is what the Ford-Fulkerson algorithm says. Okay, now we'll focus on a question: how will we going to solve it? Once it is being understood by you, then uh, you can say we have completed this network flow by finding the Ford-Fulkerson algorithm. See, these are a question with uh, you can say you can expect in this order, or else a table will be given to you where the paths are get like paths are given with a capacity, might be. Okay, so here as per the question we have the graph with us, and the question is written: find a maximum flow or max flow through the given network using a Ford-Fulkerson algorithm, considering non-full forward edges. Here no backward edges are considered. So based on the non-full forward edges, how we'll find out the max flow. Okay, so as I said, in the step 1, assign all the flow, initial flow as 0. Okay, so you can check whenever we are writing, the original capacity will be always the right hand side of it. Okay, so always will keep the right hand side as our original capacity, and the left hand side is considered as the flow of the path of flow of the network. Okay, initially we said it is 0 for us. Okay, I'll change the color when I picking one by one. I'll be changing the color. I'm writing here as augmented path. Next is a residual capacity. Why I'm saying residual capacity, I'll be telling you that one. Bottleneck capacity, how do we find? So the bottleneck could be found out if the flow is 0. Initially, if the flow is 0, there is the capacity is 10, here the capacity is 4, here the capacity is 10. So the augmented path is, this one is considered as the augmented path. There are many augmented path could be formed, not an issue. If the source and sink is there in a path, we will say it's an augmented path. This is considered as a augmented path. Okay, there are many augmented path could be possible. If source and sink could be there, then we can say it's a augmented path. Then the capacity is given to us as 10 4 10. So the minimum capacity, which is 4, is considered as our bottleneck capacity. Okay, we can say it's a bottleneck capacity, but the initial flow should be 0, then only we can say it's a bottleneck capacity. Then for the residual capacity, how do we find? Initially it is 0, so for this the residual will be 10, which is the original capacity, minus the flow is 0. So the residual capacity, I'm saying it is RC, residual capacity is 10. Why? Because 10 minus capacity minus flow will be your residual capacity. Here the residual capacity is 4, here the residual capacity is 10. So out of this, the minimum residual capacity will be considered as 4. So we can say the minimum capacity, residual capacity, will be selected. Okay, this is how we will be knowing the concept. So based on the idea, we first the prerequisites which we studied, first we'll complete this one, then only we go in depth of this problem. It's done now. Augmented path, like you can have a table, might be the table could be having 4 5 rows based on the augmented path which you have selected. So I'm just creating it in such way. which might be helpful for us in future. So whenever I'm picking, so I'm just changing the color here. Initially I'm just picking this as green. So whenever you are finding the answer, you always think the source to sync, the best way is this one and this one. Okay, so you can do one by one. Okay, so this would be better. Like, why? Because whenever we do not have any conflict, here also we can expect no conflict. Whenever we are finding, you just remember the minimum capacity, which is 4, will be selected. Why? Because the residual capacity is 0. Each augmented path, whenever we are finding, always the residual capacity of any path will be 0. Will be finding out. You can check here. I'm just putting it green. So I'll start the flow, finding the flow there. Here I'm finding the flow. Out of this, whichever the minimum residual capacity we found, we have to select this one. So S, then A, then B, then T. This is what the augmented path is. So the minimum residual capacity is 4. Here we can find, because 10, 4, 10, the minimum is 4. So what we have to do, we have to add it. It is written there. So what we have to do, previous flow plus current residual capacity. Previous flow was 0, current residual capacity is 4, so total flow will be 4. This is what how we can find it out. Previously the flow was 0 and the residual capacity we have selected is 4. That's why it is updated as 4. Okay, is updated as 4. Here also it is updated as 4. Why? Because previous flow plus selected residual capacity will be considered as the current flow of this augmented path. So here I will say the residual capacity is 4 now. Okay. You could have to write it bottleneck capacity, not an issue. If it initial flow is 0, you can write it bottleneck capacity. Sometimes we'll expect the repetition of it. That's why we can say we have to stop that. Okay, by saying bottleneck capacity. Here 4 minus 4 is 0. That's why we said we just put a circle. By making it, this path could not be used further. Why? Because the residual capacity is 0. You can say you can read up to 4 hours, and if 4 hours is given as an assignment, you cannot flow like other students are having, like S to A and B to T. There are two different students who are having, they are dedicating 10 hours for study, and you are dedicating 4 hours of study. So the capacity we have to maintain like 4 hours only. If I'll enhance it, so you cannot overcome it, because our target is the pipe shouldn't be burst. The pipe should have its own capacity. Max to max, this much capacity could be available, not an issue for us. If I'll say no, 5 hours of assignments you have to do by any means, there is certain rules now. You cannot go ahead of it. You have dedicated 4 hours, means the 4 hours will be dedicated to you. The study, whatever the thing is that you have decided, like 4 hours means 4 hours. So within the 4 hours, if I'll be doing, so this is how we are releasing the pressure, or we are managing the pressure. Okay. So for this augmented path, we said residual capacity is 0. For here, the residual capacity will be considered as the original capacity minus the flow which we selected is, this is what our residual capacity, which is RC. Now residual capacity, based on the residual capacity we will be doing, but initially what we are doing, we are focusing on non-conflict one. Okay, like here the first one will be non-conflict for us, that this one also non-conflict for us. Here the minimum we have like 9 is the minimum. Why? Because 10, 10 and 9, the minimum will be selected. Okay, so whenever we add it to the flow, here this will be added a previous flow plus the selected residual capacity, which is 9, then you put 9 here. Okay, so I'm just cutting this one. Always you write in this, like you cut this and you write it 9. The main reason of writing this means you are updating the flow. Okay, this is what we are doing. Or else I could have to write by omitting this. No, this is not correct. Okay, because as per the rule which is defined, we should have to follow that one. So the augmented path is S to C, then D, then T. The total residual capacity is considered as 9. Here, as I told you, whenever we are selecting augmented path, definitely any of these paths, like 4 paths could be selected, 5 paths could be selected. Definitely one augmented means definitely the residual capacity of any path could be 0, more than 1 or at least 1. Definitely will have the residual capacity of 0. Here you can say 9 minus 9, the capacity minus flow is 0. That's why what we did, like we put a circle, like we'll not choose further, because through this we cannot go ahead. Like here there are 3 students, 9 hours is the maximum hours for a student, like he or she cannot go further, but other students have 10 hours, so we cannot follow the 10 hours, no? We could have to like manage the pressure, so definitely we follow the less one. Okay, whenever the class is running smooth, if all the students will understand, that doesn't mean that only fast venture students will understand or second venture students will understand. This is not what we have to do. We have to go for like whatever the students are, like 18 students or 20 students, if all students will understand, then only we can go ahead. This is what the releasing of pressure or maintaining of a class. Okay, next we have done this augmented path. Now I'm changing the color. You can check path could be established like based on the residual. Right now we are working with the initial 0. Now we started from source to whether we have to we have to find whether there is any other path could be established or being possible or not. Here the residual capacity we have to always keep in mind. Here the residual capacity is 6. I'm just saying the residual capacity by in a color. Whenever I'm doing the finding out the residual capacity, 10 minus 4 is 6 is our residual capacity. Here the residual capacity is 8 minus 0 is 8. Here the residual capacity, like from this it could be a possible direction. So from this we can write 6 minus 0 is 6. Okay, so here the residual capacity we can expect is 10 minus 4, which is 6. So out of this 6, 8, 6, then 6, out of this we have the minimum one, which is 6. That's why we are focusing on the residual. That's why I am writing it here as residual. Otherwise I could have the option to write it bottleneck. We will work first time, second time it up to you, like we can work with the bottleneck, not an issue. But further directions or further finding the augmented path is based on the residual capacity. That's why I'm writing the residual capacity in this side. Okay, so whenever we are going to choose this one, we have to first find out the residual capacity. So the residual capacity is 10 minus 4, like original capacity minus the flow. Okay, so that's why I have to select the minimum one. The minimum you can check is this 6. Okay, or else if you have any doubt, you can check other paths too. Clear? So other paths, suppose other paths you are going to check, this one also a path could be established, but here I have selected this one, so that's why I am following this path. Right now we have the minimum is 6. I'm just using this one as a row for us. Next this, next this, next this. This is one path we have selected, S to A, then A to D, then B, B to T. There are 4, 1, 2, 3, 4, 4 edges are there. So the residual capacity we have selected is 6. Okay, once we are selecting, what we are doing, you just check it. Once the residual capacity we have selected is 6, 4 plus 6 is 10. We have to write there as 10. The updating value is 10 now. Okay, next, it's previously it was 0, now it will be updated as 6. 0 plus 6 is 6. 6 is the flow now. Next, here is 0 previously existing, now we put 6. Here previously it was 4, now it will be considered as 10. Why? Because current residual capacity which you found are definitely the previous flow will be added. So here 10 we found residual capacity, here we found residual capacity 0, here we found residual capacity as 0. I said, one example I have given through which I said definitely whenever we found an augmented path, there at least one path is considered as the residual capacity is having 0. Residual capacity having 0 means we cannot go further, we cannot accommodate further, we cannot flow further if the capacity is finalized. As per the capacity, we made the flow. More than a capacity, flow could not be there. Like you say, suppose capacity is 6, the flow could not be 7 for each path. Definitely we have to keep in mind. So here in this path which we found is, and now changing the color. Okay, this is what we found as our augmented paths. And if you have any doubt like can we do further, you can check. Here is the residual capacity is 1, here the residual capacity is 0. From here I can switch, but from here only one path is there through which we can reach to sync, so augmented path could not be found. That's why we have to stop it. Clear? Once we are stopping, like to find a max flow or maximum flow, the answer could be the augmented path, the residual, the sum of all the residual capacity which you have collected. 4 plus 9 plus 6, total is 19. This is what the answer is. The max flow or maximum flow we can find in this directions. First we'll keep an augmented path, whether the augmented path could be formed well. If yes, the residual capacity will focus, the minimum residual capacity will be selected. Okay, this is how we have completed the Ford-Fulkerson algorithm, and we can find out the max flow. The next video will have like mean cut, and how through mean cut how we'll say the mean cut will be the max flow. So I hope it is understood by you. So thank you for watching. Have a good day.